all letters are numbers, some numbers are not squares. So some not type of a statement, be careful, right? Some not. So all letters are numbers. How do you draw the basic diagram? All letters are numbers. All letters are numbers, and some numbers are not squares. Some numbers are not squares. Remember, some numbers are not squares. Which region are we referring to? Let me do some highlighting to explain this to you. Yeah. Here, let's say some numbers are, if you read this statement, some numbers are not squares. Some numbers are not square, right? This orange statement here refers to this region. The outside numbers which are lying outside. Some numbers are not squares. These numbers, not the... See, the problem, as always I have mentioned, is for some A's are B's and some A's are not B's, the basic diagram is the same. But the region that we refer to is different. If it was some numbers are squares, we would have referred to this overlapping region. But when we say some numbers are not squares, we refer to the external region. Yeah, external region. So basically some numbers are not squares represents this orange area. Okay, that's only for the sake of clarity, right? Clear explanation. You can't have these tools in the exam. You don't have these tools in the exam. So don't get used to it, but yeah, you should always understand that we are referring to the external region. Some numbers are not squares, right? All letters are numbers, some numbers are not squares. So these outside numbers are not squares. Now look at conclusions. The first one, some squares are not letters. Some squares are not letters. Again, in the conclusions also we have some not type of a statement. Some squares are not letters. A some not type of a statement. Some squares are not letters. Now it's usually a little difficult to verify some not type of conclusion. Right, some not type of conclusion. He says some squares are not letters. So if you look at the diagram here, yes, I can conclude that some squares are not letters. In fact, all the squares are not letters, but all the squares are not letters also means that some squares are not letters. Yeah. But will it always be true and all that is a confusion, right? This is the basic diagram. Remember, this is a basic diagram, not the possible diagram. So some squares are not letters satisfies the basic diagram. I can say these squares are not letters. These outside squares are not letters. But we have to check the possible diagrams. We have to confirm from the possible diagrams as well. Only then we can say that is a definite conclusion. But then I have a different way of solving such questions. I mean, whenever we have some not type of conclusion, instead of trying to draw all the possible diagrams and doing stuff to verify whether this conclusion really follows or not, what we can do is check the converse. See, for some squares are not letters, what's the converse? Now you may get a little confused. What do you mean by converse? Converse here, I mean the complementary conclusion for some squares are not letters. You understand complementary pairs? Complementary pairs, there are two types, right? What is the first complementary pair type? First complementary pair type is like this. Some A's are B's and no A is B. No A is B. This is one complementary pair, right? Some A's are B's and no A is B. What's the other one? All A's are B's. All A's are B's, or some A's are not B's. Some A's are not B's. Now, if you look at this conclusion here, some squares are not letters. This is what is given. Some A's are not letters. Some A's are not B's. Some squares are not letters. Now, a better way of verifying this is to check the converse. What happens if I take all A's are B's? He has given some A's are not B's. What happens if I take all A's are B's? So instead of verifying for some squares are not letters, let's try and see what happens if all squares are letters. What happens if all squares are letters? Can all squares be letters? Can all squares be letters? Can all the squares be letters? You're able to follow? Some squares are not letters. Can all the squares be letters? What happens if you take all the squares inside letters? Automatically all the squares go inside numbers. Are you able to follow? Draw the diagram. Some squares are not letters. I'm trying to do that. Some squares are not letters. I'm taking all the squares. I'm taking this part. All squares are letters. So all squares are letters. All the squares are letters. And all letters are numbers. Now go back to the statements and verify. Have you violated anything? All letters are numbers? Yes, all letters are numbers. That statement holds true. Some numbers are not squares? Yes, some numbers are not squares. That statement also still holds true. Outside numbers are not squares. Yes or no? All letters are numbers is satisfied. All the letters are numbers. All the letters are numbers. Some numbers are not squares is also satisfied. Outside numbers are not squares. Which means by taking the converse, which is all squares are letters, we don't violate anything, right? We are not violating anything. So that is true. That is true. All squares are letters is true. All squares are letters is true, right? We can always say that all squares, we can say that all squares are letters. It is not violating any of the statements here. So which means all squares are letters can be true. And in this particular possible diagram, when you say all squares are letters, this particular conclusion fails. Some squares are not letters fails. You are able to follow the logic? This is a possible diagram that I have drawn. But I have drawn the possible diagram taking the converse of this given conclusion. Converse here is nothing but the complementary part of this conclusion. So when I draw all squares are letters, I don't violate any of the statements. Both the statements are followed. And which means all squares can be letters. If all squares can be letters, how can you say some squares are not letters? See, some squares are not letters fails in this possible diagram. It satisfied the basic diagram. Some squares are not letters satisfied the basic diagram, but it failed in this possible diagram. It failed in this possible diagram, right? Some squares are not. Which squares are not letters? All the squares are letters. All the squares are inside letters. If all the squares are inside letters, I cannot say that some squares are not letters. So this is a wrong conclusion. First one does not follow. It clears the basic diagram but fails in the possible diagram. Remember the technique that we had used? We are not verifying for this conclusion. We are verifying for the complementary part of this conclusion. And since the complementary part is satisfied in that possible diagram, this part does not satisfy the possible diagram. And hence it is wrong. Okay? This is a little tricky. You have to practice a few questions to understand what we have done here, right? Anyway, first one does not follow. Second conclusion, some numbers are letters. Some numbers are letters is a basic conclusion. I mean, if all letters are numbers, the definite conclusion is some numbers are letters. For all A's are B's, what is the definite conclusion? Some B's are A's. All A's are B's. You don't even have to draw the diagram for this one. For all A's are B's, the definite conclusion is some B's are A's. So for all letters are numbers, definite conclusion is some numbers are letters. So only 2 follows. Option B has to be the answer. Only 2 follows. Option B has to be the answer. And please do not go by the length of the explanation. It has taken a little time to explain the solution, but when you solve it yourself, it doesn't take so much of time, right? It takes about 45 seconds in this particular case, just because there are some not type of statements and some not type of conclusions. Be a little careful when you have some not type of statements and conclusions. Okay, final answer is only conclusion 2 follows.